Hi, everybody. So the lesson is going to be today on simplifying rational expressions. So I told you guys that operations with rational expressions was going to be what we get into, and simplifying is a part of that. Um, this math that we're going to be doing today, it's not that the math itself is difficult. One thing that I think will be challenging is people just, it requires a lot more ability to, what am I trying to say? Like, see patterns. There isn't like a prescripted, always do this step, and this step. It's kind of a few different options, and you have to be able to look at it and kind of tell which you should go for. So that's how it's difficult for some people, but I think that the best way to get better at that, to make it easier, is practice. So I'm going to do several examples for you, and it all comes back to factoring. So before we start factoring, let me introduce you to this concept. You know how when we have something like this, and then we say to solve for x, divide both sides by 4, and then we say these cancel out, okay? Have you ever wondered why these cancel out, right? Well, we know that division cancels out multiplication, but really what's happening here is that 4 divided by 4 is 1, so it ends up being 1x, which, as we all know, is just x. So really we're doing, basically, if you have something at the top being multiplied, and you have it at the bottom being multiplied or by itself, then it cancels out because it just becomes 1, and having timesing something by 1 doesn't matter. Okay? So key to simplifying rational expressions is remembering that when you have something on top and you have something on bottom, let's say like this, these will still cancel out, and you'll just have x over y. That is the most important thing to know, and that's going to be the basis around which we build all our factoring and simplifying of rational expressions, is if something's multiplied on top and multiplied on bottom, it cancels out. Notice this, nothing cancels out because it is not being multiplied, it is being added. Dividing does not do anything to cancel out addition. So this yes, this no, nothing cancels out here, okay? It has to be being multiplied in order to cancel out on the top and bottom. Not added, not subtracted. Okay, so basically, simplifying rational expressions is you take some big complicated looking thing, you factor it as much as you can, and then you cancel out what you can cancel out. So we have kind of 3 types of factoring. 2 of them we learned the other day, right? The greatest common factor, when you take out an x or take out a number. We've got the difference of squares that we did the other day. And then we've got the one that we learned a few weeks ago and earlier in life, which is the factoring quadratics. Of the form x squared plus bx plus c. So that's the one where we use the x method and we find what multiplies to this, what adds to this, etc. And so a rational expression might require any or all of these different types of factoring. And you need to be able to look at the expression and tell what kind of factoring you're going to need. Okay? So, let me see. I want to do this one. 8x to the fourth plus 32x cubed over 32x. So if we think about our three different types of factoring that we've been playing around with, nothing here looks like factoring quadratics, right? There's not even any x squared. There's no x squared plus bx plus c. So we're not going to do that. Difference of squares, there's also still no squares. Now, just because there's squares doesn't always mean you have to do one of these, but in this case, if there are no squares, you can't do them. So we're talking about greatest common factor. So using the skills that we did earlier this week, we're going to factor out a greatest common factor between each of these. So if we think about just the top here, we've got two terms, 8x to the fourth, so that's 8 times x times x times x times x, and 32x cubed. Now, what do they have in common? They've got x, 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 x. This one has an extra x, but oh well. What about 8 and 32? So don't forget, we got to deal with the numbers as well. So numbers that go into 8, 1, 8, 2, 4. And 32, well, we got 1 and 32. 32 is even, so 2 and 16, not 3, and 4 and 8. Okay? So the greatest number that goes into both of these, so they both have 1, they both have 2, they both have 4, and they both have 8, but we only care about the biggest one, which is 8. So we're going to rewrite this as 8 times 1 times x, and you don't even really need the 1, right? And this as 8 times 4 times x times x times x. So now we have another factor they have in common. So rewriting this, we've got out front 8 and 3 x's. So 8x cubed, and inside 1x, which is just x, plus 4. Down here, 32x, got that. Okay, how do I explain how I get to this? Right here, now essentially we're going to see what's on top and what's on bottom that's being multiplied. So the top multiplication is 8 times x times x times x times x plus 4. On the bottom, we've got 32 times x. So we're trying to see what's on the top and the bottom. Well, we've got 1x on the top and the bottom. And what else we have is an 8, because 32 is 8 times 4, just like we discovered over there. So, just like when we divide both sides, anything being multiplied, this is being multiplied, right? It's times. Multiplied on top and bottom gets canceled out. So those pieces in purple get canceled out. And our final product, we have 2 x's here, so that's x squared. We have our x plus 4 term, and then on the bottom we just have 4. Can't see that very well. Isn't the glare? I apologize. Okay. So this would be your final simplified answer. So we applied this GCF factoring, right? There weren't any quadratics, there weren't any squares, so we didn't do the other two. We factored out the greatest common factor from the top, and then we factored the bottom to see what we could cancel with the top. Okay, so we canceled the 8 by splitting 32 into 8 times 4, and then the 1x that we had on the top and the bottom. Okay, oh boy, I'm one example in. It's already 10 minutes long. It's going to be a long video. I'm going to fall asleep watching this 5 times. Okay. X squared plus 10x plus 25 over x squared minus 25. So, looking at our options here, this top part, x squared plus 10x plus 25, that looks like that. That looks like the x squared plus bx plus c. So the first thing you should do is see if we can do that x method factoring on this. So, go over here. Multiplying to make c, adding to make b, same old regular stuff. C is 25, B is 10. So numbers that multiply to make 25 aren't that many. 1 times 25 or 5 times 5. And I bet you can guess which one of these adds to 10. Okay, so that means that this factors out to x plus 5 times x plus 5. All right, because 5 and 5 were our two mystery numbers. Now down here we've got x squared minus 25. Now it doesn't look exactly like this because it doesn't have a b, but if you remember that 25 is 5 squared, which you should remember because we just did it here, then you can recognize this as one of our x squared minus, I think I used g squared problems. So x squared minus g squared, 25 is 5 squared. So if you recall, this factors into x plus g and x minus g. So this would factor into x plus 5 and x minus 5 because 25 is 5 squared. So I'm going to write that here, x plus 5, x minus 5. So what can cancel out on the top and the bottom? Remember, we can only cancel out with multiplication. So what I have is x plus 5 multiplied by x plus 5, and x plus 5 multiplied by x minus 5. So what I see on top and bottom is one of those x plus 5s. Can you even see that I've crossed that off? Okay. One of the x plus 5s is being multiplied on top and multiplied on bottom. So what's left is x plus 5 over x minus 5. And this cannot be simplified anymore because there's no more multiplication, right? We can't cancel out the x's or cancel out the 5s because they're not being multiplied. So that's your final answer. So this big scary looking thing is just x plus 5 over x minus 5. Hopefully that sounds good. Okay. Let's see, let's see. So here's a little bit of a twist. All right, so looking at this, top and the bottom, on top I see x squared minus 9. Now if you know your squares, you would know that 9 is 3 squared. Okay? So this would factor into x plus 3 and x minus 3 by law of this, right? X squared minus 3 squared equals x plus 3, x minus 3. Now down here at the bottom, 2x cubed plus 6x squared. Well, this has a square, but it's not a difference of squares. Heck, it's not a difference at all. It's being added. And it's not a quadratic like this, because it has this x cubed, right? It's actually a cubic. So what we're looking at here is a GCF one. So first term, second term. First is 2 and then x cubed, so x times x times x. Bottom is 6 times x times x. We've got 1x in both of them. Got 2 x's in both of them. And now I got to look at the numbers. So 2 is a prime number. So the only numbers that go into 2 are 1 and 2. 6, on the other hand, has 1 and 6, and it also has 2 and 3. So 2 is the biggest number there. So we can call this 1 times 2 if you want, or just keep it at 2. And 6 we're going to turn into 3 times 2. Okay. So everything that we have circled goes out front. So 2 and then 2 x's, so x squared. 2x squared. And then what we have inside stays inside. So 1x, so that's just x, plus, then over here, it's just 3. So now we've got x plus 3 times x minus 3. And here we've got 2x squared, or you could even say 2 times x squared, times x plus 3. So what's on the top and the bottom? X plus 3. We end up with x minus 3 over 2x squared. All right. Okay. Whew. So that is another example. I'll do one more. All right. So both of these are squares. I mean quadratics. Squares, quadratics, whatever. But neither of them have any singular number at the end, right? They both just have x. There's no plus c, there's no g squared that are usually numbers. That's a sign that it's still GCF, even though it's squared, even though it's a quadratic, okay? Because the thing is, if there's no singular numbers, everything has x in it, then I'm already thinking, I can factor out x. They all have an x, okay? So let's do our GCF with this. So 2 terms at the top, x times x, and 6 times x. Obviously, we've got an x for both of those. And this one doesn't have any numbers, so the 6 just stays. So you factor out x, you've got x left, and you have minus, and then here you have 6 left. Okay. Now down here, 6x squared, so 6 times x, and 36x, so 36 times x. Now you have 2 numbers, so you want to see what they have in common. So we just did 6, that was 1, 2, 3, and 6. 36, whew, we've got 1, 36, 2, 18, 3, 12, 4, 9, and 6 times 6. Okay? So 6 is the largest one that they both have in common. So if we rewrite 36 as 6 times 6, then they each have a 6, and they each have an x. Okay? So 6x is in both of them. And then we've got x inside on the top, minus, and then 6 inside. So let's see what we can cancel out here. We've got x times x minus 6, 6 times x minus 6. So you might notice most clearly x minus 6 is in both. So that gets canceled out. But there's more. Look what else is on the top and the bottom. X. X is on the top and the bottom. Okay, so that gets canceled out too. That's still being multiplied. So on the top, you've canceled out everything. Okay, cancel out everything. So what do we put? Someone's going to say 0. It's not 0. When you've canceled out everything, you just put 1. You know how there's an invisible 1 in front of an x? You can imagine that this basically is 1 times x times whatever, right? So there's still a 1. On the bottom, we've canceled out both of this, so it's just 1/6. I like problems like this that look real complicated to begin with, and then it turns out it's the same thing as just writing 1/6. That's my jam. Okay, I'm going to stop the video now before it gets too obscenely long.